Swayam Prabha. Digital India. Educated India.
Let us understand what are the basic concepts in mechanics that we will be looking at in this course and what are the equations that connects them. Okay. So, now I am interested in, I am going to concentrate on concepts and equations in mechanics. Okay. So, there are 4 concepts in mechanics. Essentially what we are trying to do is relate force to the displacement. Okay. Now, we are not going to relate them directly, but we are going to relate them through 2 other quantities called as stress and strain. Let us first understand why do you need these 2 concepts and why can't you relate force and displacement directly. Okay. The reason is the following. Say I have a bar to which I am applying a load P. Okay. Let us assume this bar is, this is the bar, let us assume the bar is made of steel and or rubber. Okay. For the same force P, let us assume that this bar deforms into another bar of this shape. Okay. So, it has elongated by amount delta. Now, is the relationship between the force and the displacement delta the same for steel and rubber? No, right. Steel will deform much less compared to rubber bar. Okay. So, we find that there is dependence on the material. So, this shows there is a material dependence on the relationship between force and the displacement. Okay. So, there is a material dependence on the relationship between force and the displacement. Next, let us say I have 2 bars, one bar is thicker than the other one and I have another bar which is longer than this bar 1. Let us say this is bar 1, this is bar 2 and this is bar 3. Now, which one will show a longer elongation, or which of these, let us say this is delta 1, I apply a force and this expands by delta 2 and this expands by delta 3. I have applied a force P on each of these bars and the corresponding elongation undergone is delta 1, delta 2 and delta 3, and I am assuming the length of bar 3 is greater than length of bar 1, area of bar 3 is equal to area of bar 1, then I know that delta 3 will be greater than delta 1. Longer bar will elongate more. In case of bar 2, let us assume length of bar 2 is same as length of bar 1, but area of bar 2 is greater than area of bar 1. This would imply delta 2 would be less than delta 1. In other words, the geometry of the body has a role to play in determining what this function is. So, there is material dependence and then there is a geometric dependence. Okay. If you want to relate the force and displacement directly, such a relationship will depend upon both the material and the geometry of the body. So, you will not have any predictive capability of such a relationship. In other words, I have to find this function will have some constants. So, I have to do some experiments to find the constants. Once I find the constants and relate the force and displacement, I can't use that relationship to understand what will happen for a different geometry of the body, or when the body is